Boersma. As you can see, the title is Domain-Specific Languages, which means we need a domain, and the domain happens to be people making data models. The goal is to have some tooling to input such models, and a solution would be a DSL implementation. If you want to code along with me, then the setup instructions are in one of my GitHub repos. I will show you the plan for what we're going to do today. So we start at the top left box. I'm going to cheat a little bit and show you the end result first. After having demoed the Goal app, I'm going to set up the development environment shortly. We'll be using a JavaScript-based development environment based on JavaScript first of all, React, MobX for state management, and Parcel to get the whole thing running on any modern browser. After that, we're first going to create an AST. And once we have an AST, we're going to project it. And by the way, that AST will be deriving basically from the demo app. To project the AST, we'll be using React. Then we're left with a nice projection of the AST, but it's not editable yet. So the next thing we'll do is we make the AST editable. And for that, we also need to use MobX to make things observable so that edit actions actually have an influence on the projection of the AST. In order to make that AST editable, I'm also going to introduce something that I like to call edit state. All right, and then after we did all this AST trickery, we also want to do something with it, and that is generate code. So I'll be making a code generator, a small one for this. And the final thing we're going to do is we're also going to validate this AST a little bit. If you checked out the coding or the setup instructions, and so clone the repo and follow the other instructions in there, you can use any IDE to open a repo. I happen to be using IntelliJ most of the time because that's what I'm usually using also in a day job. But you can also use things like Visual Studio Code or anything else. In fact, the bundling that we need and that we're using Parcel for runs off any command line interface or off of any terminal. So you can also use Vim if you like. Wouldn't entirely recommend it, but if you really want, you can do that. So let's quickly go through the repository. The main thing is, of course, the source folder that has a pre-baked index.html file with basic necessity. It references an index.jsx file, which has the basic React stuff. One component function, one React component function, which doesn't do anything yet. And then a render function, which calls that component function and renders it. And we also include some styling, which we'll not look at because I'm not such a CSS wizard, so I can get things somewhat reasonable looking. Earlier I said I was going to demo the Goal app we're going to make in this development environment, so let me do that. So this is the eventual Goal. See a couple of things here. There's a section data model, which has subsections entities and relations. Entirely what you would expect for a data model. You could prefer a graphical layout for this. That's entirely possible with this kind of technology as well. But for the moment, I happen to choose a rather simple textual layout. So here you see the entities. Every entity line describes an entity, which is the the name here in the greenish box. For every entity, you also give the plural name, so you can talk about singular and plural names in relations. We're going to see that in a moment. And an entity has a kind, and some entities you can derive a certain kind, but other entities you have to indicate whether they are a kernel entity or a reference entity, and you can switch between the two by just clicking on kernel or reference. So if you look beneath the word reference here, let me highlight that a little bit. You'll see an ugly greenish color, and that means that this entity happens to be a reference entity. And behind that, there is a text which should hold a description. Well, there's no description yet, so let's put that in. An order. So an order describes a request for a certain product. No, that's not entirely correct. Let's say for certain products. Order line describes a request for a certain product as part of an order. Okay. You also see some things happening below. We'll get to that in a moment. So, and there's also relations in this data model. So one relation is this one. It's the first one, saying that each order holds one or more order lines. So, and I can change this thing, so I can also say an order line. Should be able to say an order line. It's not working apparently, so that's the first bug. Holds one or more order lines, or at most one order line. Well, that doesn't make so much sense, so let's change that back to one or more order lines. And what you see here is that if I select at most one, the singular name is used, and if I say hold one or more, a plural name is used. So that nicely updates depending on what you put in here in this box. There's also one other thing that sneakily updates itself. That's, if you look here at the word an, because in English it's an order. But if we're talking about a product order, for example, then it should be a. And that nicely updates that as well. So I want to emphasize that because we're creating a domain-specific language. If you're somewhat familiar with the topic or heard about it, you also probably heard about things like parsing and such. And that's something we're not going to do today because we're using a completely different paradigm from parsing. So this is not a textual DSL. It looks like text, but it doesn't look like the kind of text you would have in an IDE, for example. So this is really nice, nice text which you would find in a real web app, and not just a box of monospace text. So that has certain advantages. The first example is that it looks nice because you can apply all kinds of styling. This goes also a little bit beyond syntax highlighting. You can do a lot with syntax highlighting, but with projectional editing, as it's called, you can do a lot more and have a lot more influence on the visualization based on your DSL content. The rest of the Go app, there's also a box generated code down here. So that already has the generator working. Also here you see this is a very simple textual output. I could also have made a SQL table definition here. Maybe we'll change that. We'll see. And also there you can see that as soon as something changes here in the DSL content here in the data model, then it updates immediately in the generated code here. Let me get back to the development environment. So I'll switch to my IDE again. So let's look at the index.jsx. And oh yeah, the way we run this, that's using I happen to be using Yarn, but you can also use npm for running stuff. And in fact, we don't need Yarn so much. We can also just use the actual command. Apart from that, that needs npx in front of it. Parcel bundler is taking the contents of the source. And of course, I took the wrong thing. Contents of the source. Builds that, starts up a web server, and also watches this code. So whenever I change something in the code, the parcel bundler detects those changes, picks them up, rebuilds the whole thing, and also sends a signal to my browser that things have changed and that it should reload, which it then does. This is very convenient. So let me go to the browser. So this is the goal application, so I'll now switch to the real one, and that says do stuff, which is not much yet. For now, I'll switch back to the goal implementation, because the first thing we're going to do is not make a projection, but make an AST, a so-called AST. So let me explain a little bit more about ASTs. AST stands for Abstract Syntax Tree. AST stands for Abstract Syntax Tree. Maybe the most important thing is we rarely see ASTs in the flesh, as it were. If you, for example, would do parsing, so you would make a parsed DSL using a parser that parses plain text into an AST, you would still not see the AST so much, because in that context, the AST is very much an intermediate product, and the actual DSL content is formed by the text in the text editor. So basically the plain text, the stream of characters, that's your base DSL content. And then a parser turns that into an AST under the hood, as it were. And then all kinds of things happen with that AST. But you rarely see that AST in the flesh in real life. That's different for projectional editing, where you really turn it around and start from the AST. And you still might not see the AST so much concretely. Well, yeah, it is an abstract syntax tree, so it ought to be abstract, but it's very explicit in your code, and you really drive the entire projection with the AST. And in this case, we're going to be deriving an AST from the demo content that we have, and coding that up directly into code. That's a bit of the difficult thing with abstract things, is that they ought to be abstract, and as soon as you write them down, they're not abstract anymore, but concrete. But yeah, at one point you have to put stuff into the computer, into code. Otherwise, we're not going to be able to do anything with it. The first thing we're going to be doing is deriving some information from this projection. So we're basically reverse engineering the goal app and derive an AST out of that. Let's first look at things we can recognize. And one of the things that are easily recognizable are entities. So here we have an entity. Let me highlight the thing entirely. So what does an entity have? Well, first of all, it's called an entity. If I were to write that information down, then it would look like this. So this is the first entity, which is a box with a label entity, a singular name, which I abbreviated as SN, and with order, and a plural name, which I abbreviated as PN, with orders, and then a description, which I abbreviated as DESE, with, well, empty, basically. So we have a second entity as well. Same thing. Entity, which is a box, and the singular and plural names, and the description. Okay, so that takes care of the entities. The kind part we're going to get to later on, hopefully. So next up are the relations. And now the nice thing is this relation refers to entities. So instead of having to spell out in the relation box, so let me first show what I drew up. I have a box with relation as the label, the phrase holds, and a cardinality at least one, or one or more. So, but now we have to still put the information about the references to the orders in, and these are really references because I can only choose one of the entities I have here. I think I call this one, oh yeah, left and right. So the first thing is the left entity reference, and the second one is the right entity reference. So I'll draw those in. So this is a reference from the relation box going over the relation called left, and it's going to the order entity. And the second reference relation, second reference is going from this relation box over the right property to the second entity called order line. So let's also put the second relation in. We end up with this. So same thing. I made some cartouches for the relation names, or for the reference type names. So we can see these are both the right and left, and that's not right because I have to switch them around. This is going to be messy. No one is going to be able to read this anymore, but we'll get to that in code later on. So this doesn't look like a tree at all. So we have to make it like a tree. Oh yeah, now trees are shaped, of course, as usual, upside down. Of course, everything in computers is upside down trees. And now let's make a actual tree of our DSL content. And the way I'm going to do that, I'm going to put a data model. So one type of relations so far, which is the reference relation, which goes from one box or one object in the AST diagram to another one. We'll see now the other kind, which is the parent-child or containment relation. So here we have the data model, AST object. I like to call these objects, these boxes. You can also call them nodes, whatever you want, but I have to choose one word, and I choose object. And the entities are the children of this data model object through the entities relation, and the relation AST objects are the children of the data model object through the relations property. Let's make some code for that, because now we have this diagram and we can make some actual code for that. So let me go to the IDE, and I'm going to create a new file, which is example ast.js. Yes, I guess I want to add that to Git. So, and the funny thing, of course, with this diagram is now we have to, it makes sense to for each object in this diagram to make an object, but we have to be a little bit careful about the order in which we make these objects. I first start with the entity objects. I hope I guess this is readable. So first I make a JavaScript object for the first entity. Let's call it entity. Why did I call it in the... Sorry, I have to... No, I called it order. have to cheat a little bit here. So, and an order, well, we know it has a concept, which happens to be entity. And it has some values for its properties. And I put it on a separate sub-object, which I call settings. So we have a singular name, which is order, and we have a plural name, which is orders. Okay, so all fine. So we also have the entity order line, which I put in a constant called order line. It also has a concept. Also has settings. It has a singular name, which is order line. It has a plural name, which is order lines. Okay, so all good. Well, next up, we want to have a relation. So these things I am going to call relation 1 and relation 2 apparently. No worries. So the concept we had here was a relation. This is a little bit ugly. So one thing that I would like to do is I create a separate file which is called concepts. And in that I define this one. I will copy paste. I'm giving away, I'm spoilering a little bit here. So I define some constants with the names of the concepts, and I put them into constants which have the same name as their contents. So basically, this is like a cheap JavaScript enumeration. And instead of using these strings here, I can now just import these things. So I will import, I guess I will in the end import everything, but for now I will import entity and relation. I can just remove these things. And this makes it a tiny bit safer. Okay, so also a relation object will have a settings sub object. And it will have a left or left hand, apparently I call it. And now we want to point to order. But this is problematic in practice because this is a JavaScript object reference. But in JavaScript, you cannot really distinguish between objects which you are containing or objects which you are referencing, but because basically you're always just referencing things. And they exist somewhere else, and you can reference them through a object reference. But we also need to know whether something is an actual reference in the sense of our AST, whether there is a dotted line here, or whether we have a solid line here. So we need to use a little trick, and the trick I use is that I put this into a subject sub-object itself, which happens to have only one property with key, ref, and then the orders. So the way this works, and the way you can use it, is that if you encounter an object somewhere, then you can always recognize it's whether it's an AST object, because it will have a concept key value pair, a settings key value pair, and basically nothing else. And as soon as you encounter a setting which is an object, such as this one, you will know, or you can distinguish, or you can tell which type it is, whether it's a reference or a parent-child or a containment relation, by looking at whether it has just a ref key value pair, in which case it's definitely a reference. And if it's of this shape, so it is an object and it has a concept property and a settings property, then you will know it's an actual AST object, which is a child of the enclosing object. So in this case, we know it's a reference because here we have ref. Okay, so let's also do right hand, same way. And there we reference order line. And we have a couple of other settings to do because we have a phrase. And the phrase is holds. And the cardinality is 1 or more. You could also make some cheap JavaScript enums for these kinds of things because they are enums as well. In fact, we could even put the property names in cheap enums, but let's not do that right now. Okay, so we also have a second relation. Again, it really is a relation. It has a left hand and the rest I will copy. Not because I'm lazy, well I am, but also because we might run out of time otherwise. Now we have 4 of the boxes in this diagram, but we need a 5th one, which is the data model thing. So let's make that one as well. So another const, which is again an AST object. Oh yeah, I guess I need the data model constant here. So, and it has settings. And one of the properties is entities, which is an array consisting of order and order line. And we also have relations, which I also put in an array, and it's relation 1 and relation 2. So we see here that order was important, because basically you need to wire this up from first start with things which have no dependencies on other objects, and then you go to the things which are dependent on that. So for example, the relations, and then finally you end up with stuff that is dependent on basically everything else. In case you have cycles, it's a bit different thing, but we're not worrying about that today. So now we have an AST. Great. Let me very quickly go back to the plan. This was the plan. Where are we in the plan? So we are in the plan here we did the creation of the AST, so now we're going to the projection of the AST. So we have to change something here in app. And what we have to change is we need to import the example AST. So, by the way, the idiom of JavaScript I'm using is, I guess it's ES 2016. Yeah, it's probably 2016 with everything that we'll be using. So Parcel takes care of compiling this down to a JavaScript idiom or JavaScript source that is actually runnable by most modern browsers without problem. So if you look at the stuff that the JavaScript code that Parcel generates, it looks quite different from this. So one of the things it does, for example, at least I guess, is that these kind of const arrow function declaration, Parcel turns those into old-fashioned function declarations, which work just as well. But I happen to like this syntax a lot better than than the function syntax, although we have to use the other one as well sometimes. Yeah, let's do stuff. I'll create a new file which I call projection.jsx. I will also import the React stuff into that, and I'm going to make a React component. Keep forgetting that syntax. So we will pass it a value. It sounds a bit more general than just an object. In practice, it will be an object. But yeah, this is part of a more general pattern, which is the depth first tree traversal, which is very useful for going through ASTs in a very organized manner. And I happen to be using that pattern in the book, so this thing happens to be a depth first tree traversal as well, essentially. So that's why I take this uses code pattern, and that's why we are calling this a value instead of something else. And the way we're going to call that is, well, we'll change this app a little bit. So what we'll do there is a div, and we're going to call this projection. So it gets auto-added. Oh yeah, one of the things that Parcel does is it adds semicolons. Obviously, I have to put in these semicolons, but I really hate semicolons. So I'm not going to do them. And Parcel puts them in, and usually the whole parsing is just fine. So I'm not bothering with them. So this projection component, which we now imported through this thing, this import statement, it receives one value, and we put in the example AST, and then it should just project. So let's return something here. I had an idea for that. This is that, which I'm just going to copy in. Namely that right now for everything we put in there, it will just return a text that there's nothing defined for this specific value. Okay, so if I save this, it will run this, and I have to go to the actual, and indeed we see, oh, there's no projection defined for value object. Great. Exactly what we expected, in fact. So let's change that. We go back to the code. And the first thing that seems to be healthy is that we're going to check whether this thing is actually an AST object. Because if it's not, then yeah, don't know what we're going to do with that yet, but we'll see. That also means that we somehow have to recognize whether this is the thing we put in there is an actual AST object. I'm going to copy a little bit of code for that. We don't need to export here just yet. So the first thing I copied in is a function which checks whether some value is a JavaScript object, a real object, and not an array object. And the second function uses that one to check whether it's a value is really a JavaScript object and not an array or a string. And it also checks whether concept is in value and settings is in value. That's the only thing it does. So if that is the case, then we know we have an AST object. Great. So what can we do? in this case, well, we can switch on the concept, because we know here we can also use data model. So the first thing we might want to do is do something for data model, because that was the outermost or the root of the AST. So that's the first thing we're going to encounter, because that's what we're actually putting in. If we go back to example AST here, this is the example AST. It's indeed a data model. That's what we're exporting. That's what we're importing here again, and that's what we're putting into this projection thing. So now we go back to projection and do something here. And let's make a div with h3 in it, and then we have another div, and we have some we have some entities in there. I happen to have made some styling for this, so I will just put this in. So this will take care of some indentation and such. And the next trick I'm going to be using is some destructuring. So we know that value is right now a JavaScript object which has a concept, but it also has settings, and I want to destructure these settings. So I do this. In case you never have seen this, this is called destructuring. So essentially it does exactly the same thing as this. And in fact, IntelliJ recognizes that. So, but I like this syntax much better, and we're in fact also using it here because this is also destructuring. So now we have a settings constant which we can access directly, and we know it will have an entities entry, which is an array. So we're going to map over it. This is again a JavaScript arrow function. So we map up, we take the entities out of that, and we also use the index. And now we're going to do a funny thing, because we're going to be calling projection again. And obviously, is it obvious? Maybe not. So we're going to pass this projection thing for value entity. And we also have to pass the index into a key attribute, because React demands that we do that. So let's have a look at the result. Okay, that's a bit better. So we now see that we have indeed a data model thing, an entities title, and then 2 times the no projection defined for value object. Great. Well, that's indeed where we wanted to be. Now let me get back to the IDE scene. So now we know we can, oh yeah, let me also add a default case here. Oh, this is just fall through, so it will just fall through to this thing, which is fine. So our case is entity. So in this case, we'll return a div, and in the div we'll have a couple of things which I'm also for time reason just going to copy in. So first we have the indefinite, so the a or the n, and that's I call it a keyword. That's, or I give it a style keywords. It's a bit of a flashback to the parsing days, I guess, in some sense. So that has to inspect the singular name and the well, let's do the singular name first. It's maybe a bit easier. And also so singular name, that should appear. Then we have some other semi-crap which I'm going to copy here and copy in. I don't know where you are, but for me it's almost 9 o'clock in the evening, so I'm starting to run on fumes at the moment. And that's why, might explain why sometimes a little bit of Dutch creeps in. So, plural name, then we have to close that with, yeah, I'm not going to put everything in. Oh yeah, the scribes the kind I will put in later or not at all, depending on how far we get. So spam, and then we have the description, and finally we can just copy this line. We'll have a dot. Okay, let's see what things look like now. So actually this does not look what we want at all yet, but we'll get there in the end. So we're missing the A or N. For that I'm going to cheat a little again. I will create a file called textutils. And we'll copy those in. So these are some JavaScript functions that one is the function to turn the first character of a word into, or first character of a string into an uppercase character. And the other one is given a next word like order or a line, it will determine whether you need an A or an N, and it does some. It uses a regular expression for that. This does not fail safe because English is a weird language. But anyway, as soon as it starts with a, what is it, consonant? Yeah. As long as the next word starts with a consonant, the N will get added, and otherwise nothing will get. Don't see that here in code. Put it here. So nothing will get added if it starts with a vowel, or the other way around. Anyway, this works. So I'll put it into projection. So I want to have with first. So what we added was these functions, which I talked about, which turns, the second one turns the first character into an uppercase character, and the first one determines whether you need A or N. And I'm using those here. And what it looks like then is, indeed you say N, and this already changes because let me now sneakily adjust the AST. So if I turn order into product order, you'll actually see a product order instead of N. So that works.